Hi everyone, this is your crazy oceanography professor coming to you from, well, definitely not a plate boundary. I'm coming to you from my back porch, and in front of me is a package of store brand Hannaford cream O's. I'm a professor on a budget, balling on a budget here, and so I can't afford the real Oreos. Actually, to me, these taste exactly the same. But what I wanted to do today is show just a little bit about how plate boundaries actually work. And so I'm going to try doing something that I have not yet done before, so sorry if it doesn't work out. But with these Oreos here, they are going to represent tectonic plates. And so we've got an area of relatively rigid cookie, and it's on a layer of more, well, not quite plastic, so this isn't totally the consistency of the mantle, but it's actually a reasonably close approximation. It's solid, the upper mantle is actually solid, but it can actually, if you compress it, it can kind of hold its shape, and so in many ways it resembles a little bit like this cream or icing in between the two slabs of harder cookie here. And we're going to ignore the bottom slab here, it's just going to hold up the icing here. First thing I want to show you is I want to talk about the first kind of plate boundary, which is called a divergent plate boundary. And what I can do here is I can break the cookie. It didn't quite break in the center, but we could diverge the plate boundary, and there we go. So that's our divergent plate boundary, and I'm going to leave that here so we can take a look at that. The second is going to be a convergent plate boundary. And again, I'm going to break the cookie right there, and I'm going to have this be two tectonic plates that are roughly the same density. So we're going to say these are two continental plates, and they come together in the convergent boundary, and they actually form a mountain. So these are two plates that come together. They're coming together like this, and they cause the surface to go up. The third is going to be two plates that are different densities. So again, we're going to have a convergent boundary here. I'm going to break it apart, but this one on this side is going to be lighter than the other one. So this is going to be a heavy plate, and that's going to go down, and the light plate here is going to go on top of it. So you might be able to see here, and I'm going to try to pull this in a little bit closer. We've had one plate go underneath the other. That's called subduction. The third plate that we're going to have here, again, we're going to have a break in the cookie, break in the top there, is going to be what we call a transform plate boundary. So there's nothing rising, there's nothing falling, except for the bottom of the cookie here. But what happens is one plate moves off to one side, the other plate moves off to the other side, like that. So we've got examples here on this table of really four different kinds of plate boundaries. We have just the traditional divergent plate boundary, which is right there. Again, some of it came apart, and you can see the spreading right there. Here we have a convergent plate boundary, two continental plates where the mountains built. The Himalayas are a great example of that. We have a subduction situation. Again, this is a coming together, but one plate rides on top, and the other, this is the oceanic plate, the dense plate filled with mafic rocks like basalt. That one gets subducted underneath. And then lastly, we have our transform boundary. This is like the San Andreas Fault out in California, where one is going one way, one's going the other way. You could have a fault here where the motion, if you're looking across, has gone to the left. We call this a left lateral fault. You could also have the same type of motion, but if you're looking across it, it goes to the right. We call that a right lateral fault. So I probably should have gotten a fifth Oreo cookie, but this kind of works for our, we can call this a transform fault, or a strike slip fault is another way of talking about this kind of boundary.